Welcome back to another exciting chemistry lessons. In this lesson, we are going to learn how to use the periodic table to determine the chemical and the physical properties of an element. Well, first of all, if we look at the key on the periodic table, we notice that each element has an atomic number. And of course, it also has an element symbol which represents an element name. Then of course we have the average atomic mass, which we will learn how to use that later. But sometimes we don't use the term symbols to represent the element symbols, but we use something else, a little more fancy. We call it chemical formula. So what is the chemical formula for sodium? That would be Na. So each element represented by a chemical formula. Now if we look at the periodic table, look at the element. They are arranged based on an increasing number of atomic number. We have 1, 2, 3, and all the way to the very last element. So in a way, each atomic number, which we know is equal to the number of protons, represent a specific element. So that is the periodic table. Now, if we look at the periodic table, we notice there are group A is over there, and then we have a bunch of more group A's over here. Then in the middle, we have group B's as well. Well, the reason why they have groups A and group B is that because each type of group represents different things. Well, first of all, look at group A. Group A is basically the representative groups. And that is, each one of those groups represent a specific families of elements. And why are they in specific group? That's because they share a very similar characteristic in terms of chemical properties. So keep that in mind. And sometimes we don't use the term representative, but we use the term main groups on the periodic table. What are the main groups on the periodic table? And for the group B, they are known as the transition metals, basically all of these metals right here. So let's look at the group A one by one. There are four major main groups, or four major representative groups. The first one is in group 1A, and it has a specific name called alkali, the alkali metals, okay? And then the group 2A, it has a specific name called alkaline earth metals. Then all the way over here, we have group 7A and 8A. Those are other two major groups. And for group 7A is known as the halogens. So all the elements in group 7A are considered a halogen. All the element in group 1A is considered an alkali. And all the element in group 2A are considered an alkaline earth metals. Well, in group 1A, the only thing that we need to be aware of is the hydrogen right there. That hydrogen is an exception. It is actually a non-metals, okay? It is not a metal at all. And lastly, we have the noble gas, which is the most important groups of all, because this is the only group that is considered to be inert or stable. And we will talk more about this later, okay? But this is the structure in terms of groups for all the elements on the periodic table. And the one main thing that you need to remember is that all the elements in that groups share a very similar chemical properties. Now let's go to the number on the side. We have 1, 2, all the way through 7. These are called the periods. And they are very important later on when we talk about electrons, okay? These are periods. So we have first period, second period, third period. And that's the reason why it is number 1, 2, 3, 4, all the way to 7. And we will talk about that later, okay? So that is the general description of a periodic table. Now let's look at the other part of the periodic table. Now let's look at the electron on the periodic table. Remember we talked about how this has a number, right? And that's the reason why we don't call it first, second, and third. We use number 1, 2, and 3. That is, if we look at the overall patterns, okay? Look at all the elements in period 1. How many shells does it have? It has 1 shell. Boom. That tells you the period number is actually equal to the energy level number, or more specifically, equal to the number of shells. okay? And look at period 2. Look at that. How many shells does it have? All of them has 2 shells. And then look at number 3. How many shells does it have? All of them has 3 shells. And so on. So basically, the period number represents the energy level number or the number of shells. So again, as you go down the periodic table, what happened to the energy level is actually getting higher. So the period number represents the energy level or the number of shells. So that's one pattern on the periodic table. Let's look at the group. We talk about the group, right? 1A, 2A. In this chemistry class, we only focus on the representative groups. And that's where the majority of the patterns are going to be. Well, first of all, look at group number A. And that number right there, it's actually equal to the number of valence electron. And what are valence electron again? They are the outermost electron. And of course, where are the outermost electron? In the outer shell, okay, in the outer shell, and which in a way it is in the highest energy level. Highest energy level. So the valence electron are found in the highest energy level, which is in the outermost shell. Okay? So in this case, we have the group number A equal to the number of valence electron. For example, if this is to be group 1A, look at what happened to all the elements in group 1A. It has 1 valence electron, over here it has 1 valence electron, and it has 1 valence electron. What about 2A? The same thing. It has 2 valence electron and 2 valence electron. What about go all the way to 7A? It has 7 valence electron, of course. Look, 1, 2, 3, 4, 5, 6, 7. And the same thing to the rest of the elements in that group. The group A number, that number right there represents the valence electron, or the number of electrons in the outermost shell. Now, let's look at the most important pattern of all, is that the group 8A. This group is the only group on the periodic table that is considered stable. That means it doesn't want to bond or react with any other element. Group 8A is the only group that consists of all the elements that has a stable outermost shell. Now, think of the term stable. For an element or for an atom, when it is stable, it doesn't want to combine or doesn't want to react with any other element. And all the elements in group 8A, they don't want to react with any other elements in normal condition. So, what does that tell you about the rest of the elements on the periodic table? They are not stable at all. The outermost shell are not stable. So what do you think they're gonna do? Of course they want to be stable. But within the group 8A, how many valence electrons does each one of them have? Well, for the rest of them, all of them has 8 valence electrons. And it is so important that it actually has its own rules called the octet. What does octet rules mean? This is the rule for stability, okay? When it is octet, it is actually equal to stable, outermost shell. Think of the word octet, that is 8, okay? This is actually equal to 8. Of course, exception is helium.